Hello all, welcome back to Electronic Devices and Circuits video lecture series. I am BVV Sachinarayana, Associate Professor in Department of ECE, East Institute of Technology, Bemavaram. Unit number 3, Rectifiers and Filters. In the last lecture, we already discussed about introduction to RPS and various blocks of RPS, the waveforms of RPS unit at various blocks. Now in this video, I am trying to give some brief details about basic rectifier setup. The objectives of this lecture are what is rectifier and what are the components used in the rectifier, what is the basic setup of a rectifier circuit and what are the blocks involved in this rectifier setup, and what are the characteristics of a rectifier circuit and types of rectifiers. I already defined a rectifier is an electronic circuit which can convert AC voltage to pulsating DC by using one or more PN junction diodes. So why a diode is used in rectifier circuit means rectifier need to convert bidirectional signal means AC into the unidirectional signal DC. So it need a device which must exhibit unidirectional characteristics. That's why diode it can be used in rectifier circuit. Suppose if you consider a PN junction diode, the diode conducts when forward biased and it doesn't conduct when the diode is reverse biased. So this PN junction diode exhibits unidirectional characteristics by conducting only in one direction. That's why the rectifier is used in, that's why the diode is used in the rectifier circuits. If a AC voltage is applied to a PN junction diode, suppose during positive off cycle, diode will be forward biased and it conducts. While during the negative off cycle, diode will be reverse biased and it will not conduct at all. Thus, the conduction occurs only in one direction. So, the output voltage across the load resistance will be unidirectional. So we can easily convert a bidirectional AC voltage into a unidirectional DC voltage by using this rectifier. And the below figure it shows the general setup of a rectifier circuit, which mainly consists of 4 blocks: source, step down transformer, rectifier, and the load. And this is the general rectifier setup. In this, source means it is AC source. AC source, okay, means we are getting this from mains. From mains, we are getting this source, which is bidirectional, signal, okay. And in general, it is 230 volts, 50 hertz AC signal. So we are getting from our mains. And this signal it is given to a step down transformer. I already told in electronics we are working with very lesser voltages. That's why we need to reduce the level of the AC input signal. So we need a step down transformer. This step down transformer reduces the level of AC signal to the required DC level. So we need a very lesser voltages. So maximum 12 to 15 volts we require in electronics. So this 230 volts 50 hertz signal it can be reduced to this level with this step down transformer. Okay, so the output of step down transformer still it is bidirectional signal and very clear it's still AC. Okay, so this bidirectional AC signal with reduced level is applied to the rectifier. And I already told this rectifier consists of one or more diodes. The rectifier it can exhibit unidirectional characteristics. So this rectifier circuit can easily convert this bidirectional signal to unidirectional signal, and that unidirectional is applied to our load. Okay. So because of the characteristics of the diode used in the rectifier circuit, so this negative off cycle, it is converted to the positive off cycle. So the output of the rectifier is unidirectional. Okay. So in general, we want a DC, perfect DC, but the output of the rectifier is unidirectional. It consists of so much of AC component. That's why the output of the rectifier, we are calling it as a pulsating DC. Pulsating DC. There is some large amount of AC component. There is large amount of AC component in the output of the rectifier. That's why it is a pulsating DC. Suppose if you want a perfect DC, then the output of the rectifier must be converted to output of the rectifier must be applied to filter before applying it to the load. So here I am considering only the rectifier. That's why the output of the rectifier is directly given to the load. So with rectifier, we are getting a pulsating DC, but not perfect DC. There is more AC component in the output of the rectifier. Then coming to the characteristics of rectifier, there are so many characteristics parameters for the rectifier circuit. The first one is average DC load current, average DC load voltage. I already told the output of the rectifier is pulsating DC, which consists of so much of AC component. Still, it is time varying. Okay, it is unidirectional, but it's a time varying component. So we need to calculate the average values, average load voltage and average load current for these circuits. Okay, so maybe this is average current, I average or average load voltage. Likewise, you need to calculate for the output of the rectifier. Okay, and the third parameter is RMS value of load current. So in general, AC values are expressed by using RMS. So there is some AC component in the output of the rectifier. So we need to calculate the RMS value of that load current. Then how much DC output power we are getting in the rectifier output, we need to calculate. That is DC power output. And how much AC input power is supplied to the rectifier, that must also be calculated. And if you know the output power and input power, then we can easily calculate the efficiency of the rectifier. So rectifier efficiency is equal to DC output power by AC input power. That gives the rectifier efficiency. Means this rectifier efficiency describes how much of AC input power is converted into DC output power. Then ripple factor. I already told in the rectifier output there is some AC component. So how much AC component present in the rectifier output is given by a parameter called ripple factor. That's why it is given as AC component by DC component by DC component. AC component by DC component, that gives the ripple factor. And peak inverse voltage. Peak inverse voltage means the maximum voltage drop across the diode in reverse bias. Maximum voltage drop across reverse bias diode. Reverse biased diode. So the name itself says it's a peak inverse. Peak means maximum, inverse means reverse bias. Okay, if the diode is reverse bias, how much voltage we are getting across the diode is given by a parameter called peak inverse voltage, PIB. Transformer utilization factor. So in our rectifier setup, there is a transformer, and how effectively this transformer is utilized in converting AC input power to DC output power is given by a parameter called transformer utilization factor. And next, regulation, voltage regulation. So voltage regulation, it gives the difference in between no load voltage to full load voltage. The difference in between no load voltage to full load voltage, you can call it as a voltage regulation. Ideally, this voltage regulation must be zero. There should not be any difference from no load to full load. So it's a power supply which must always give the same output voltage. So there should not be any difference from no load to full load. So ideally it is zero, but practically it's having some value. Okay. So that is voltage regulation. And next one, form factor, peak factor. So form factor means RMS value by DC value, RMS value by DC value. And peak factor means peak value by DC value. So these are the some of the important characteristics of a rectifier. For every rectifier circuit, you can calculate these parameters. Then types of rectifiers. So in general, there are two types of rectifiers. There are two types of rectifiers. In general, there are two types of rectifiers based on the conduction angle and the number of diodes used in the rectifier circuit. The first one is off wave rectifier. So off wave rectifier means there is a off wave conduction, off conduction for full input cycle. Off conduction for full input cycle. Full input cycle. In general, in this off wave rectifier, only one diode is used. Only one diode is sufficient to convert bidirectional AC to unidirectional DC. Then full wave rectifier. Full wave rectifier means there is a full conduction for full input cycle. Full wave conduction. Full conduction for full input cycle. Full input cycle. Okay. In there are two types of full wave rectifiers: center tapped full wave rectifier and bridge full wave rectifier. So in center tapped full wave rectifier, a center tapped transformer is used and two diodes we are using. Whereas the bridge rectifier, the no need of any center tapped transformer, but four diodes are used in the bridge rectifier circuit. For these two rectifier circuits, center tapped rectifier and bridge rectifier, there is a full conduction for full input cycle. Okay. And in off wave rectifier, no center tapped transformer. We are using normal transformer in off wave rectifier and normal transformer in bridge rectifier. Whereas in center tapped full wave rectifier only, we are using a center tapped transformer. So in general, we are saying that there are three types of rectifiers. Three types of rectifiers in general. So the first one is off wave rectifier. Second one, center tapped full wave rectifier. And the third one, bridge rectifier. Okay, this is the general classification of the rectifiers, bridge rectifier. For all these three rectifier circuits, we can calculate all these characteristics. All these characteristics we can calculate. Then coming to the summary. In this lecture, we learned the following. So what is a rectifier and what are the components used? What are the components used in the rectifier circuit? And the basic setup of rectifier circuit, the various characteristics of rectifier circuit, and the types of rectifier. Thank you all.